Myself Ajit Kumar, a BTech from IIT BHU. I am introducing conceptual learning in physics. It is needed because very often it is seen that the students, while solving the problems in physics, are confused about the fundamental facts and the basics involved. That is why very often in the solution of the problems, the facts, fundamentals and basics involved are skipped. That's why the concept building in the minds of a student does not take place properly. That's why they usually fail to solve a problem in right way. I am introducing this conceptual learning in physics to enable them to solve a problem in physics from very fundamental and from very basics, so that they may adopt a correct approach and did not commit any mistake of any kind. कॉन्सेप्चुअल लर्निंग इन फिजिक्स की आवश्यकता इसलिए पड़ी क्योंकि क्योंकि फिजिक्स में बहुत जगह ये प्रायः देखा जाता है कि जो फंडामेंटल प्रिंसिपल्स रहते हैं और बेसिक्स रहते हैं उनको स्किप कर दिया जाता है और केवल सोल्यूशन दे दिया जाता है, जिससे कि स्टूडेंट्स के दिमाग में टोटल पिक्चर क्लियर नहीं हो पाती है और कॉन्सेप्ट बिल्डिंग नहीं हो पाती है और वो प्रॉब्लम सॉल्व करने में सही अप्रोच का इस्तेमाल न करते हुए गलती करते हैं। तो इसलिए यह प्रयास ये है कि इन प्रॉब्लम्स को एकदम बेसिक से शुरू करते हुए सारे फंडामेंटल्स और फैक्ट्स को इन्वॉल्व करते हुए हर स्टेप पर हर बेसिक क्लियर करते हुए सॉल्व करते हुए छात्रों को इस तरह से प्रशिक्षित किया जाए कि किसी भी एग्जाम में वो कोई भी प्रॉब्लम फिजिक्स की आसानी से सही अप्रोच के साथ टैकल करके here I have selected 14 problems in 3 lessons just to show the fundamental approach in physics and how to start from the basics to have a right approach and to work out the correct solution of the problem. Now I want to start with some problems to clear my approach and whatever I want to do. So please listen carefully. Now I am picking the first problem from lesson 1, that is involving angular momentum, moment of inertia and rotational motion of a body. Very often we have seen the concept of angular momentum, the concept of momentum, the concept of moment of inertia and the rotational motion and the mutual relationship is not cleared enough, so that there are the students face a lot of problems in solving this type problems of this type. So I am approaching the first problem. नेट गलती हो गई है। वो कहाँ गया? सॉरी, ये है ना, बस मिटा सकते हैं ना। चलो मिटा दिया, हो गया। इसी से पढ़ा नहीं, के ले लेते हैं। हम्म, बोल रहे हैं ना, बोल दिया ना। A disk AB is rotating around ZZ axis and it is inclined with the vertical at an angle theta. The rod connecting it with the point O is perpendicular with the is perpendicular at the center G of the disk. Disk. In some way, the disk slips on the rod OG, but it maintains the angle of 90 degree with its axis and rod OG. The OG changes from L to L1 and it is required to find out the change the angular velocity in this condition. In this picture, the axis of rotating disk is A B, and the vertical is A1 B1, and the vertical A1 B1 is parallel to ZZ axis. Now, the moment of inertia of an object is always taken about an axis, and the angular momentum of an object is always calculated around a point. Now, when we want to calculate the moment of inertia of disk AB about ZZ axis, so it is first of all required to calculate the moment of inertia of the disk about an axis parallel to ZZ axis or vertical axis passing through its center of gravity, which is I A1 B1, and that is equal to I A B cos square theta, that is equal to MR square by 4 into cos square theta, where MR square by 4 is the moment of inertia of the disk about axis AB of the disk. Now, to find the moment of inertia of the disk about IZZ, the axis A1 B1 is vertical and parallel to ZZ axis. That it is required to calculate the moment of inertia of the disk about A1 B1 because it is parallel to ZZ axis first, and thereafter the mass into the perpendicular distance between A1 B1. To find the moment of inertia about ZZ axis, we first calculate the moment of inertia of the disk about axis A1 B1, which is parallel to ZZ axis, and thereafter the perpendicular distance between A1 B1 or a vertical through G and ZZ dash is calculated, and in this I A1 B1, the mass of the disk multiplied by the square of this distance is added to find out the moment of inertia of the disk about ZZ dash, which will be like that: M R square 4 cos square theta plus mass into length. The perpendicular distance is L cos theta. So that means L cos theta square. And as the angular momentum is conserved in absence of any torque, and no any external torque is being applied on this disk, that's why the angular momentum is conserved. So we can write L is equal to, where L is angular momentum, L is equal to I1 omega 1 is equal to I2 omega 2. Then you can find out easily the omega 2 is equal to I1 omega 1 बटा में I2. In this way, the change angular velocity can be computed. Now, as we want to calculate the angular momentum of the disk about OO, that will be simply I1 omega 1 into I1 omega 1. That will be simply I1 omega 1.